Everybody, I'm going to be talking about the rate of chemical reactions, that is chemical kinetics. What is chemical kinetics? Chemical kinetics deals with the speed, velocity and motion of a chemical reaction. Chemical kinetics. Chemical kinetics deals with the speed, velocity and motion of chemical reaction. When we are talking about chemical kinetics, we are talking about the speed or the velocity or the motion at which a chemical reaction occurs. Now, for a chemical reaction to occur, it must be what? It must be accompanied by what? Energy. Chemical reaction must be accompanied by energy. Which is heat. So when we are talking about the rate of chemical reaction is the rate at which a reactant is being used up, or a product being formed, So you have to talk about the rate at which the reaction proceeds. It can be the rate at which a chemical reaction occurs, or how slow or how fast a chemical reaction is. There are some chemical reactions that proceed very fast, and they can be the rate at which the reactant is being used up, or the product being formed during the chemical reaction. So the formula is the rate of reaction is equal to amount of reactants used up over the time taken, or the amount of product formed over time taken. Or the rate of reaction can also be equal to the amount of product formed or obtained over the time taken. Rate of reaction can also be defined as what? The amount of the product formed or obtained over time taken. Can also be defined as the volume of gas obtained. Over the time taken too. The volume of gas obtained or produced over the time taken. There are some reactions that are very fast. Example of reaction that are very fast, e.g., number one, we have explosion of petrol. Very fast when you ignite them. Precipitation is also part. Precipitation reaction is also very fast. Then just normal fast, you have neutralization. Neutralization is normal, but then slow. We have roasting of iron, roasting, fermentation. Fermentation is a slow reaction. Fermentation is a slow reaction. So fermentation is a slow reaction. Then let me proceed. Now let's assume a reaction between A plus B to give us this product C plus D. This is my reactant side. Reactants. Why this is the product? Product. So in a chemical reaction, there must be what? A new substance is being formed. When A and B react together, C and D is being formed. Then when we are talking about the rate of reaction for this, for the reactant side, it's always negative. Reactant side is always negative, while the product side is always positive. So, rate of reaction for this negative side, now say change in negative, change in the amount over the time taken is also equal to what? Minus D, change the amount of B over the T is equal to positive C over the T, and it's equal to D change in D over the T. The amount is the same thing as mole. The amount or mole, which formula is equal to mass in gram over molar mass in gram per mole, can also be equal to volume in dm cube or cm cube over 22.4 dm cube or 22,400 cm cube, or concentration or the concentration times volume in dm cube, or the mole or the amount, is equal to concentration in mole per dm cube times volume in dm cube. Then can also be equal to number of particles. The particle can be ions, atoms, electrons over Avogadro's constants. Avogadro's constants, which is equal to 6.02 times 10 to the power 23, or pressure in dm cube, pressure in atm times volume in dm cube over gas constants, value 0.0082 atm dm cube per mole per Kelvin, times absolute temperature must be what? Kelvin. So you should remember all these 5 formula that have been written on the board. We said that what? The rate of reaction is the what? The rate at which the reactants is being used up. or the rate at which the product is being obtained. Now this is the rate curve. You can use the gradient to find the rate of reaction. You can take the gradient. This is my time in minutes, volume in cm cube. So let's say this is V1, C1, C2, V2. So rate of reaction for this, the rate of reaction equal to V2 minus V1 over T2 minus T1, which is unit is cm cube per minute. Cm cube per minute. You may be given a equation, maybe a magnesium ribbon reacts with dilute excess hydrochloric acid, and you are asked to draw the graph. Maybe you are given a graph. Now just note that, let's take notes like this. Now let us say volume of hydrogen gas produced, then time in seconds or minutes. Let's use minutes. Then this is 0, 1, 2, 3, 4, 5, 6, 7. Let's go. 10, 20, 30, 40 in cm cube. Now immediately the graph going like this, the rate of reaction is increasing like this, going up. Let it get to this place at a steady rate. As you get to this point, this is where the reaction stop. The reaction stop at this place. Let's call this place S. So at this place, the product is being formed. Maybe the hydrogen gas is being formed at 4 minutes. So the reaction is stopped at what? 4 minutes, completely formed. The product is obtained at this point, 4 minutes. And the volume that was obtained, let's say is for 39 cm cube. So the product that is being obtained is 49 minutes. Now, example now. Let's solve a question. Let's solve a question. 6 grams of magnesium. Example 1. 6 grams of